I would like to really start by talking about this molecule. So as a professor, I have to talk about, in chemistry, I have to talk about chemistry. And I'm sometimes a bit surprised when I hear in the media that we are going for a carbon-free society. Then I'm a bit surprised because look to me, look to you. In this morning, you had some breakfast, you had this element carbon. And actually, when you're breathing, you breathe out this molecule, which is actually a bit substantial because you're doing about a half ton per year, you're emitting this kind of CO2. Now, what I want to say is that when we talk about carbon, we are somehow now a bit, I would say, carbon dioxide, but we like carbon. And in the left, you see diamonds are forever and carbon is there. And carbon also had a lot of positive things because even now we are negative about coal. It actually has made possible that we have our industrial revolution. It has made it possible to make all our goods around us. And recently, we also realized that it also did something else. We have been making not only this kind of plastic tubes, actually we also have been making devices which helped us out during this COVID corona period. And here I have also one of these. These are made out of material which is carbon-based. But we also have to be fair that we're also talking now about chemistry, carbon, in a more negative aspect. You can see that you have this plastic waste. So what you see is that we are now in an era where things which we took for granted are not anymore the case. So that means that we will have to do something with this molecule. We will have to take this molecule, rip it apart, and take it as a resource, as something where we can make something valuable out of it. Here I show you a movie. On the right, you see the increase of the global temperature, actually starting from 1850, and we later on started also measuring the CO2. This is the whole issue. Not that we only are emitting CO2, but also that it has an effect on our climate. And because of this, with all these agreements, Paris agreements, Glasgow, and so on, and many will come so to make sure that we make this transition happen. I took this picture when I was with my family in the LA, Los Angeles area. On the left, you see the skyline. Well, skyline, you can barely see the skyscraper there. On the right, you can see the solar panels, the windmills. And also here, all over Europe, you see more and more of these solar panels and windmills. These are two sides of the same coin. Actually, what we see is, on one hand, the pressure to do something. On the other hand, our willingness also to do something. And that has to merge. That has to give us this transition, which makes that possible. I want to be positive. Sometimes I hear people complaining, actually, about COVID. We complain also all a lot. But you have to be positive. And as a professor, I feel that I have to really bring further the next generation. And that means that I would like to come back to something which was my youth. Here you see in Belgium, actually I was born not so far from Leuven, here with my family, the circle, that's me. We are in the 1970s. And what we saw was dying trees, acid rain. Do we talk about acid rain? No, we don't talk about acid rain. We solved a lot of our issues, ozone and so on. So we are ready to make this challenge again, and ready to take action and solve this. Now, I would like to show this picture as well on wastewater treatment plants. Now, you can think, wastewater treatment plants, but back to the Middle Ages. Did we have this? No, we did not have that. Actually, only around the industrial age that started to develop. In the early days, for example, in the city where I'm living, in Utrecht, the water, the rain had to clean up and bring it into the canal. What I'm pleading for is that we have now to develop very advanced, not only wastewater treatment plants, but air systems, cleaning systems, where we are grabbing, for example, CO2 and converting it to something useful. And we have to do that stepwise, not only positivism, but also realism. I think we have to make sure that we take the technology which is on the shelves, transform now what we can do, and then develop the new technology at the same time so that we are ready in 2050 to take up the challenge. I would like to introduce you a new logo. This is the logo on CO2. It's a stop sign, and CO2 is a linear molecule, but it has this oxygen in red, which is rounded. It's a ball, it's circular. So we have to transform our society linear economy in a circular economy and make use of this molecule step by step. We want to design the refinery of the future. Nobody knows what the refinery of the future will look like. We have some ideas. Every one of us has ideas how we could do that. But more important is that we take the refineries of now and transform them step by step towards that ideal scenario where we have full circularity, full sustainability. So here I show you one of the elephants in the room. There are several elephants in the room when we want to build this refinery of the future. The first is scaling up. On the left, you see an installation which we have in our lab at Utrecht where we convert CO2 to something useful. On the right, you see a pilot or already a larger installation. We have to bridge. We have to work together. We have to cooperate and bring that what is on our shelves towards industrialization. That needs effort. That needs time and also money, but also legislation to make that possible. The second real elephant in the room is that we have an enormous size. We have an enormous challenge. Here I have crude oil. Well, crude oil, we have about, let's say, 500-600 refineries. We use 100 million barrels, 159 liters, per day. It's about 14 million tons per day. To make it more visual, huge stadiums, football stadiums like this one, 7 to 8 or so per day. And I'm only talking about crude oil, not about talking coal, not about natural gas. That is the renewable energy we will need to get it circular. That's a gigantic operation, not be done in 5 or 10 years, step by step. Another thing is we need science. It's already alluded that we have, of course, a lot of technology. We have already a lot of science available. And here I have this ball. And I want to talk about this powder you put in that reactor. And when you zoom in, zoom in, zoom in, then you come into the world of atoms and molecules. And this metal nanoparticle is able, for example, to convert CO2 to make fuels, ethylene, whatever. We have to work on this. We have to design these particles to make them more efficient, stable, and work on the conditions so that they can operate in the new world, for example, electrolysis. Another elephant in the room is we have not to use only CO2. We have to use all our waste. Waste is a resource. Plastic, agricultural, municipal, biomass. Can we make our molecules? Can we make our materials from these? Another elephant in the room is materials, critical raw materials. Maybe I forgot to say that when you have this refinery of the future and you want to build something similar, assume 600 refineries of 80,000 barrels oil equivalent. Do you know what it cost, the APEC? It cost about 7.5 trillion euros. Money is one thing. I'm quite sure after Corona, we know that we can do that. But we need also the critical raw materials. And that is not only platinum and gold or whatever. It are base metals, which we considered as normal. So we will go from a non-renewable fossil towards another non-renewable resource. Base metals, minerals, and we will have to harvest them also in a sustainable manner. So we will have to make sure that our mining operations will become more sustainable and cleaner. We need them for everything. Copper for electrocatalysis, for example. Nickel for batteries. We need lithium. We need cobalt. We need other elements. And all those have to be provided in large scales to make it possible. And that means we also have to recycle them. There's another critical raw material, and that is the people, the next generation, the students. And as a professor, I find it very important. It was mentioned, papers are important, patents are important. In my opinion, at least at my age, I'm now saying people are the most important. They do it. They are our critical raw material, and material in a rather other sense that I mean. We have to educate them not only with chemistry or with other disciplines, physics, biology, but we also have to make sure that they become connectors, that they are able to connect to society, to industry, to us. If you are able to do that, I'm quite sure that the future is bright. Thank you very much.